Yeah, cool. We're going to do a live episode of Swift Talk today. And in fact, not just one, not just two, but 3 live episodes compressed into one sort of meta episode.
Exactly. So the idea is to show a pattern that we ran across, and we used this pattern again and again, and we are not going to explain it with a lot of words up front. We just start with the examples. And
let's do it.
So you go first.
Okay, cool. So we have this little app over here. So one of the things we do that we cut out is switching the keyboard.
That's the ugly part you don't see, the behind the scenes part.
So we'll run this app, and it's a very basic app. It's very ugly. That's not the point. It has a stack view with, you can hardly see it probably, but there's at the top half, there's a text view, and at the bottom half, there's a button. And if you click on the text view, and if we press Command K, then the keyboard shows up and it covers the button. You all know this problem. Normally you use UI table view controller and it's solved, and it sort of resizes the table view to the size. We don't have that, so we need to fix it. So let's do that. And we can look at the notification center and take the default center and then add an observer and listen for the keyboard will show notification. So that's for the autocomplete, we need to do this one, and then we say UI keyboard will show. And we don't need an object or a queue, and we do want this block. So here we get our note in, and because we're going to deal with self, it's always good to write weak self in this case. And now that we have the note, we need to get the frame out. So this is stored in the user info. And actually, we can just quickly look at the documentation, because this is how you know this. Like, you can all read this, right? Sorry, it's not the point. The point is that if you click on this, you see the documentation, and here it lists all the different keys. Obviously, we prepared, so we know what key to use. So we can say note.userinfo. This is optional. We know that we can force unwrap it. It's going to be there. That's in the documentation. So we can force unwrap it, and then we can get the keyboard end frame. Let's see if we get auto-completion. Oh, yep, there it was. Almost.
Don't scare it.
Yeah. So this is a CG rect. And again, we know this from the documentation, but it's not very apparent in the API. So we're going to force cast it to a CG rect.
It's kind of ugly code, right?
Yeah, it's very ugly. So this is the end frame, and now we can finally use it. So we can say bottom layout constraint, bottom layout constraint .constant, and then set the end frame height. It's always weird that the only thing, I don't know who came up with this, but somebody's mentioned the only thing.
There's a self missing.
Oh yeah, there's a self missing. The only thing that changes about a layout constraint is the constant. It's the only changeable part. So we almost got it. We need a question mark, of course, because self is weak. And now it should work. And basically, we're done with the first app, except that we're going to add a lot more code to do the same thing. So let's see if it works. Now we click on it, and now it sizes correctly. So that's the easy part. Do you want to take it from here?
Yeah, so that's nice, but we will try to pull out some of this ugly code here. So the idea is that we can create a struct for all the things that are in this notification, because there's a lot of different information in there, and we need many pieces of it. And to make this a bit easier, we create the struct. So some keyboard switching again here. That's how it goes. Yeah. We couldn't agree on a common keyboard so far. So this is the keyboard will show payload. And to start with, we just put in one property. So this is the end frame, which is a CG rect. And then to initialize this, we write this initializer that takes the user info dictionary, which is a dictionary from any hashable to any. And well, in there, we just do the same thing that Chris just typed out here in the notification code. So I will copy this up, paste it in here, and now we just have to fix this up, remove the let, remove the node dot. We don't need the force unwrap because it's not optional. And this is our initializer. And now that we have this payload struct, we can already use this down here, and I will just add some lines to get it a bit higher up on the screen. And instead of pulling this end frame out like this, we can just say let payload equals, and then we do keyboard payload. Yep.
Autocomplete is really slow today. I see him type, but like, yeah.
Yeah, nice. So, and then we pass in the user info dictionary, which is node.userinfo force unwrapped. And now, instead of using the end frame, we can say payload dot. And now we can use autocompletion on here as well. So we get the end frame, we can use it like this. And well, autocompletion is not that helpful if there's one property, right? But yeah, as you all know, there are tons of properties in this notification. So now I will hope that you didn't copy anything in the meantime. And if I paste, okay, so I need to use my history here. Okay, so we'll just paste in the complete version. There's nothing exciting going on. It's the same code as we wrote before, just for all the properties. And well, if I now use the autocompletion, this looks much nicer, right? Now you get all these things. They have the correct types. So let's do the end frame height again.
Yeah, this is cool. So this is really useful in a sense that you don't have to remember all these properties. You just write this struct once, and then you're basically done. Thank you. So now what we can do is combine these two pieces of information, because the keyboard will show payload only works well with the UI keyboard will show notification. So if we combine those two pieces together, then we can always make sure that they're used together. So to do that, we're going to create a struct, and we can call this notification descriptor. And this is going to be a generic struct, so I'll call it A, or we could call it payload, but A is shorter for typing. And then in here we store the name, so the notification name. And we store a way to convert this user info dictionary into the A. And in our case, we just know that it will succeed, so we can call this a parse. And parse is a function which takes one of these dictionaries, any hashable to any, and it will produce an A. And to create one of these structs, we can just say let keyboard will show equals notification descriptor. We use the name, and that's now we get nice autocomplete, hopefully. Excellent. And for the parse function, we can actually use this initializer. So we can just say keyboard will show payload.init. It already has the right type. And we could now use this directly in here, but I think it would be nicer to maybe add an extension to a notification center. Yeah,
we haven't really won too much if we just use the struct down there. So the idea now is basically to duplicate the API, the existing add observer API. And for that, I will just take the signature, whoa, this is small, out of the documentation, so the existing add observer method. And then we add an extension on notification center. And I paste in the signature, and we will just make a few little changes here. So instead of having the for name, we will just say for descriptor. And so this is not a notification name, but it's a notification descriptor. And this is generic over A, and so we have to add the A in front as well. And then we are almost good to go. But the cool thing now is that the last parameter, the block, doesn't need to take a notification anymore as parameter, but it can take an A. So we get already something typed out. And then to implement that, well, we just have to call the original add observer. So we just say add observer autocomplete, and then we pass in the information that we have in the struct. So we can say descriptor.name, and the object we just pass on, the queue we pass on, and then in this block, we can use the parse function that's on the descriptor. So we get the node in, And then we can call our block with the descriptor.parse, and we pass in the node.userinfo. We have to force unwrap this here.
Nice.
So is this correct? Let's see if this builds. I think there's still...
I think it's okay.
No, it works.
Yeah, cool. Okay, so let's use it. So over here, we can now replace that code. Sorry. So instead of this for name, we can now pass in the keyboard will show that we created. And the object stays the same, the queue stays the same, and instead of a node, we now actually get this keyboard will show payload in. It's sort of tight and bundled up. So here we can just say payload. And we don't need this line at all anymore. And everything should still compile and run. And yeah, we can add a discardable result over here.
That's a disclaimer we should add anyway, right? So we don't care about deregistering this observer currently.
That's just work. It's the same thing you need to do otherwise. Yeah. So let's see if it still works. It still works. And we really cleaned up our view controller. I think it's really nice. We sort of pulled out that code that does all the parsing and like that you always have to write over and over again and read the documentation and sort of wrapped it up in one nice bundle.
So this value here, this keyboard will show, this would be the thing that you can now use over and over.
Yeah, you just write it once.
Anywhere you need it.
Yeah. Awesome.
Okay, let's try to jump up to our next example.
Let's see if everything still works.
Yeah, we'll see. Maybe I will just quit the simulator for now.
It's always a little bit scary with the live coding because sometimes, I mean, Xcode playgrounds are really reliable. But sometimes things go wrong.
Okay. Well, we will see if that works.
Looks like it's working.
It's launching the simulator again.
Yeah.
So anyway, we can already start to tell the story about this example. So this is the networking example where we have this class, this web service class, and we have this method, load all episodes. And what this method does is just standard stuff. It uses a URL session to start a data task, to fetch the data, to parse it into JSON, and then it tries to convert the JSON into episodes, and then finally down here it calls the completion handler and hands us back the episodes. And that's pretty standard, but you don't really like it, right?
Yeah, well, the problem is that, well, there are two problems. If we scroll down a little bit, we have exactly the same code for loading a single episode, which is not really nice. Like it's a little bit different. What I find even more problematic than the code duplication is that it's really hard to test. I guess we all heard from Lisa that if you don't test, you're a monster. So yeah, we need to test somehow, or we need to make our code testable. I think that's even more important, like a first step towards testing. And now if we want to test this, we need to bring up a web server or mock all kinds of things, or like mock URL session out somehow. It's very hard to test. So I think we can maybe pull out the changing parts and
so the idea would be to use basically the same pattern, what we just did with the notifications, and to create the struct that instead of immediately doing what we want to do, describes the pieces we need in order to do what we want to do.
Yeah.
Complicated sentence. So we can define something like this, like a resource struct up here. And in this struct, we bundle up two pieces of information. The first one is the URL of the endpoint. And the second one is a parse function. And that might look familiar from the notification example. And the parse function takes the JSON and turns it into whatever we expect to come out of this particular endpoint. So we can take the JSON, which is just an any, and then we have to return something. So we need a generic parameter on the resource. And we should make it optional, maybe?
Yeah, I think it would be good. Yeah, we could also make this parse function throws, and then we get really nice error information, but I don't think we'll manage that for this talk.
So the optional is the poor man's error reporting, so to say. So it's good enough for now, right? So now we have this resource struct, and we can actually define a resource for our all episodes endpoint, so to say. So we can say all episodes, and that is just a resource of an array of episode. And then we initialize this with a URL, and we have this URL defined above. And then we need to specify the parse function. And the parse function gets the JSON in. And, well, we can basically take the code we wrote down here already. So I will pull out this line. First, we need to guard that we can cast this JSON to an array of JSON dictionaries, because that's what we expect. And if this doesn't work, we just return nil. And if this succeeded, well, then we can try to turn all these JSON dictionaries into actual episode values. And of course, we need to return that.
Nice.
And now we just need to find a way to actually use this struct to make a request.
It still compiles. So basically, we pulled out all the changing bits between load episodes and load episode with ID. And we can actually refactor load episodes. Instead of like being a very specific thing, we can make it very generic by loading a resource. So I'll call this load, and it's also going to take a resource.
That's how it looks like when he starts typing in the keyboard.
A resource.
I thought about telling you before, but it's okay.
We're among friends here. So we're going to load this resource of A. And actually, let's make it an unnamed parameter, because it's already a resource type, so we don't need to burden the user with that. Now, the completion handler, instead of taking an array of episodes, is going to take an optional A. So nil if something went wrong, and an A if it succeeded. Now, instead of this URL, we can just use resource.url.
We still have to add the generic parameter there.
Oh, yeah. Yeah, otherwise everything breaks. Here we go. So the data is fine, the JSON is fine. Now, this dict stuff is going to go out. We don't need that. Don't need the comma. Now, instead of parsing the episodes, we can just say resource.parse and then pass in the JSON. And hopefully this compiles. Now at the bottom, we need some fixing. So here, instead of saying load all episodes, we can now say load all episodes. Almost the same thing. And this works. And now the next step would be to load this episode over here, like where we want to have all the detailed information for a single episode. But the problem is that it takes this URL which has the ID in it, and like, how do we do that? Because we cannot just say like let episode resource equals. I mean, how do we know what the ID is, right?
Exactly. So in this case, we cannot just create this value once, but we have to create a function that creates a resource for any episode.
Yeah.
And we will just go with the top-level function in this example. You could as well stick this on the episode type or wherever you want to put it. And so this looks, keyboard, something like that. We will define a function that we can call episode resource. And this takes, we can even put a for label on here maybe, for ID. The ID is a string in our case. And this should return a resource of episode. And now in here, we first have to create the URL for this particular request. And luckily, we already have this down here. So I'll copy this up. And now we can return our resource. So we can say return resource of episode with this URL. And then again, we get the JSON in. And now we need to turn the JSON into an episode. And we also have this code down here already. So the first step is to just check if we can turn the JSON into a JSON dictionary. So we do a guard let here. And if this fails, we immediately return nil. Same thing as we wrote before for the all episodes resource. And then we can just return our episode. There's an initializer on it that takes a JSON dictionary. How did I call it? Dict.
So nobody's really doing JSON parsing. Yeah. It's the favorite thing, right?
It is. So now we can remove all this code. And now we should be able to execute a request for a single episode by writing episode resource
There's an
for,
S missing.
Oh yeah, I will fix this in a second. For ID1, episode resource.
Yeah.
And then, if we are lucky, this should work again.
Awesome.
Yes, there's some output.
Yeah, so this really is the same pattern applied to a very different thing. Instead of executing all this code and the loading immediately, we sort of pulled out the parts that belong to each other. So the URL and the way to turn the data, or the JSON in this case, into an A. So it's very similar to the notifications.
Yeah, and it's a nice, simple, synchronous thing to test now if you're JSON parsing. Actually.
Yeah, the only asynchronous thing we have to test is this web service class, and it even fits on the projector. That should be easy to test. So let's move on to the next example.
Next example. So to make this work, we first have to stop this little web server here. Whoa, keyboard. Yeah.
I take the blame. I'm the difficult one.
Okay, so the next example is a server-side Swift example. Mm-hmm. And so the code we start with is pretty standard code, basically no matter what framework you use or even in what language you write. It's a very common pattern to have these statements server.get, and then you specify a path you want to match on, and then you have some function that does the actual work. And so we have the similar thing here.
Yeah, so usually you do a lot more in the response function. Obviously, you would load something from the database and do all kinds of stuff. And again, we have this problem that it's hard to test. So in order to test this, we either need to mock the server somehow, or create some kind of protocol, or inspect what's inside this routed server and look at the routes that are available there. It's just a little bit difficult, and we can use exactly the same pattern, but slightly differently, to do this. Let's actually run the server and see if it still works. And then if we open up Safari, we can go to localhost 8000. Cannot connect yet.
Is it running?
I'm not sure. Should be. Oh, there we go. Yay. And we can go to /books. It's a beautiful website, so these are the books. So you have the two routes that were defined in the main.swift. And to sort of represent these routes, we can again use this trick where we create, in this case, an enum route. And we're going to have two cases, home and books. And we can then instantiate this route from a string. We can do some parsing there, but just to make things easy for today, we're going to make it the raw representable way. So we can say home equals / and books equals /books. And now we can instantiate one of these routes from a string. So instead of the routed server, we can now use sort of a more raw HTTP server.
So this doesn't do any routing for us. It just hands us the request and the response, and then we have to do everything else.
So we get like the request and respond, and we'll need a try exclamation point, and then we can delete, or I'll comment out all of this code. And now the question is like, how do we continue?
So the first thing we have to do is we have to basically replace the stuff you just commented out, so this path matching. Mm-hmm. And for that, we use our route enum now. So we can see if we can actually construct a route that is available from the path and the request. So we say if let, that's the other way around.
We don't do this on purpose.
We do this more often here on stage, right? I mean, So if let route equals route, and then we can use the raw value initializer and pass in the request's path. And then, of course, we have an else case. So in the else case, it's simple. We can just say response, and then we pass in an HTTP response with a status code of 44. And in the success case, so here now we know we had a path in the request that actually matches one of the routes we want to handle, so we need to respond with some kind of a HTTP response, the same way we did before in the previous code. And well, we could have a function that does that generates this response, but for now, for a simple example, I will just create this as a computed property on the route. So this is then route.response, and now we just need to implement that.
Yeah. Thanks. So to implement this, we'll write an extension on route. So write an extension on route, and here we now have this computed property response, which is an HTTP response. And here it's very easy because of course it's a demo app, but we just switch on self, and then we have the two cases. So either we have home, and in that case we return, let's see, we can copy paste it. We return hello world, and then in the case of books, we return all the books. Let's see, here we go. And that's basically it. And obviously, if you write a more complicated app, this wouldn't be a computed property, but it would probably be some method which would take like a database connection or all kinds of environment stuff. But for the simple demo, this works. And let's see if we can run it. And hopefully, well, it builds. And yeah, it still works. So it's a very similar pattern, right?
Yeah, in a way, it's not obvious at first glance that it is something very similar to the previous two examples, but when you think about it, it also it's the same idea of instead of immediately doing something with this stuff, you build a structure that holds the information that you need to do something later on, to interpret a request, for example.
Yeah, and the nice thing about it, because first it might feel like a little bit more code, but we can now very separately test these things. So first we can test that the route given a string is constructed correctly. So that's a separate thing to test. And if we want to test that given a route, we get the right response, we can now also do that. So we don't need to bring up a server, or we don't need to like generate complicated strings. We can just create like route.books. And obviously these are enums, so you can have associated values, you can have nested enums, so you can have like a books slash something and then do the rest in that nested enum.
Yeah, and there doesn't seem much to test right now, right? But if you have, in practice, you will have more complicated routes. You might have to parse out parameters from the URL. You might have to parse the query string. You might want to parse the body into some type thing that you want to pass along to whoever handles this route. So in practice, there is all kinds of stuff to test in this stage.
Yeah, exactly. Yeah. So it's just a nice pattern that you can use over and over again and use for many different things, just sort of this interpreter pattern.
For example, one other thing that we thought about that we didn't get into the time slot anymore is doing something very similar with a Postgres query, just an SQL query, which also bundles up the query itself with a function that can interpret the results. And so this pattern just came up again and again, and in a lot of cases it turned out pretty helpful for us.
Yeah, it's definitely not a silver bullet, but it can really clean up your code sometimes and make it very testable.
Yeah.
So if this is really like sort of like a Swift Talk episode, we need to do the clap at the end, right?
But just us, or?
Oh, maybe. If do you want to join? Like, do you want to all do the clap together?
Finish clap.
Yeah. Awesome.
Cool.
Thank you.
Thank you.